Okay, 5.3. Today's going to be all about solving exponential equations. Okay? So, step number one is to use the properties of exponents to simplify. Okay, basically what that's trying to say is I want one base on each side of the equation. Okay, then step 2 tells me that I can rewrite both bases. I want them to be the same, okay, if possible. I want to make both sides the same base. And then last but not least, if I'm able to do that, then I can just drop the bases and set the exponents equal to each other, okay? So we go to number 1 here. We ask ourselves this question. Do I have one base on each side? Yes, I do. Okay, the second question we ask ourselves is that the same base? Yes. It is. So therefore, we can just go ahead, take those exponents, set them equal to each other. And if we can't solve that equation, we might have some issues. What is the answer? 8. Yeah, x equals 8. We just subtract the 1 over. Okay, go ahead and try number 2. I'll give you a second. Do we have one base on each side? Yes. Is it the same? So what'd you do? Set them equal to each other. Yeah, same thing as what we just did before. Set them equal to each other. Solve it. How do I solve that? Okay, so you could have went a couple different directions, but yeah, minus the n over gives me 3n, minus this 5 over to the other side equals negative 12, right? Divide by 3. How many of us got negative 4? Good, we're so smart. Okay, any questions there? Moving on, okay? First question, one base on each side. Do we have that? No, we don't. Okay, so that's our first issue here. If we look, though, two bases on the left, but are they the same? Yes. When we have like bases and we're multiplying, what can we do with those exponents? Add them. Yep. So we keep the base and we add these. What is k plus 2? 2k plus 2. Now do we have one base on each side? Yes. Are they both the same? Yes. So we can just go ahead and do what we did in the other problems. 2k plus 2 equals 5k minus 1. Solve it. What do you do? Minus 2k. And plus 1. So you end up with 3 equals 3k, right? And what's k going to be? Just 1. All right, number 4. Give it a go. It's on you. Okay, one base on each side. Do we have it? No. What should we do? Add them. Add the exponents, keep the bases. So the left side's going to be 10 to the 5th. And the right side's going to be 10 to the 3v minus 7. When we add all those up. Cool. Now what? Set them equal to each other. Solve it. 12 equals 3v. Divide by 3. V equals 4. How many of us got that? Great. Love it, love it, love it. Okay. Any questions there? Pretty easy stuff so far? Not too bad? Okay. Next thing we've got problems like this one. Okay. So we ask ourselves, do we have one base on each side? Yes. But are they the same? Unfortunately, they're not, okay? So here's my first word of advice for how we deal with these, okay? My first piece of advice is we want to look at both bases that we do have, and we ask ourselves, of those two bases, which one is smaller? 6, okay? So what I'm going to try to do first, and this won't always work, okay, but sometimes it will, is I want to try to see if I can rewrite both sides to have a base of that smaller base, so 6 in this case. Okay, so what I'm going to do is I'm going to go over to the side. I'm going to write out my powers of 6. So I know 6 to the first is 6, right? What about 6 squared? 36. I don't even have to go any further. I have both numbers that I need. Okay, so the left side already has a base of 6, so technically I don't need to do anything to it. The right side, I can rewrite 36 to be 6 squared. And now, do I have the same base, one base on each side? Yeah, so now I'm able to just do the same thing as before. 2x equals 12, and x is going to be 6. That's it. Okay, I want you to go ahead and do 6, and I also want you to attempt number 7. It's a little different, but I think knowing what you know about exponents, you should be able to do it. Okay, number 6. We look at these two bases, and it's obvious they're not the same. Okay? How'd you make them the same? Yeah, so you picked the smaller one, which was 2, and then you rewrote 8 as 2 to the third power. Do we agree with Lydia? We should. She's smart. Okay? Cool. Now we just set up this problem, this equation. What is the equation I'm setting up? Yeah, p minus 7 equals 3. And what's p equal? 10. How many of you got that? I think it was most of you. Okay, awesome. Awesome, awesome. Then we go to number 7. Okay. This one looks kind of funny, right? For some reason, I don't know who taught you to do this, but when you see fractions, you just automatically freak out inside, okay? And we need to fix that. So what we're going to do on these type of problems when we're trying to find a like base, okay? Typically, we look at both bases and we ask ourselves which one is smaller, and in this case, it's obvious that the fraction would be smaller, right? Okay. However, when dealing with fractions, my next piece of advice for you is we are really just worried about the denominator when we're trying to find a like base. Okay. So if I'm comparing 7 and 7, what do you think my base should be? 7. Yeah. So the left side already has a base of 7. We'll leave it alone. The right side, how could I rewrite 1 over 7 to have a base of 7? 7 to the negative 1. Good. Got to know our exponent rules. So then we just set up that equation. 4x plus 11 equals negative 1. Solve it, right? And x is going to be, what do we think? Yeah, negative 3. What questions do we have there? Anything? No? Ladies in the back? We're good? Okay. Moving on down to number 9. Okay. We'll work through this one together. We look at both bases. Which one is smaller? 3. And let's go write out our powers of 3. So 3 to the first is 3. 3 squared is 9. 3 cubed is 27. We can stop there, can't we? Okay. So we want to rewrite 27 as 3 to the third power. So we're going to do that. Okay. However, this problem's a little bit different because that 27 already had an exponent on it. Okay. Guess what? That cannot just disappear into thin air. We've got to keep it. Okay. So we're rewriting 27 as 3 to the third. But that third power now that we have is going to have to be multiplied by the old power. Okay, so the old power stays with the new power. They just get multiplied together. Okay, and then the right side already has a base of 3. We don't have to do anything. So now my equation is this. 3 times 2x plus 6 equals 2x. And how would I solve that? Yeah, I'm going to simplify it. How do I do that? Distribute. Good. 3 times 2x. 3 times 6. Next I should minus 6x. 18 equals negative 4x, and divide by negative 4. What is 18 divided by negative 4? Give me a decimal. Negative 4.5. Okay. You also could have left it as a fraction. That would have been fine too. But you would have simplified it. It would have been negative 9 over 2. Okay. What questions do we have? Okay, go ahead and try number 10. Try number 10. Okay, what did we do on this one? What did we do? A lot of us got it right. What do we do? We're being shy. Huh? Okay, so 16 becomes 4 squared. 4 times 4 is 16. Yup. Okay. So we can change 16 to 4 squared, but what do we have to keep? Keep that y minus 3. It's being multiplied. Left side stays the same. So now my equation is what? Y plus 2. Yep, and can we go ahead and distribute that? Yeah, so that would be, you got it, 2y minus 6. Perfect. Still got to solve it all the way out though, don't we? Yeah. Subtract the y and add the 6. And what'd you get? 8, good. Do we agree with Ashley it's 8? We should. She is smart. Okay. Any questions on this first page of notes? All right, move right along. Number 11. Go to this one with me. Okay. So same process as before. We look at the bases. Which one's smaller? 25. So we're going to go write out our powers of 25. So 25 to the first is 25. And 25 squared is... Oh, yikes. 625. That's not 125, is it? It's too big. Okay, so here's the deal, guys. Listen, listen, listen. Sometimes this happens. Okay, this is the third type of problem. Okay, so sometimes the smaller of the two bases just isn't quite small enough. Okay, so sometimes we have to think even smaller and try to find a base that both of these would have in common. So if I think about 125 and I think about 25 and I'm thinking of a smaller number that could be a common base, what's the first number that comes to mind? 5. It should be 5, okay? If that wasn't the first number that came to your mind, maybe you thought 3 or 4, even though those aren't factors of 25, okay? You could go and write out your powers of 3 and 4 and you're going to realize pretty quickly, hey, that didn't work. I picked the wrong number. Okay, but in this case, it is going to be 5. So we'll go write out our powers of 5. 5 to the first is 5. 5 squared is 5 cubed is. Ooh, and we can stop there, can't we? That's all we need. So 125 we would rewrite as 5 to the third, and we're going to keep that y, so that just becomes 5 to the 3y. And then the right side, 25, is going to be rewritten as 5 squared. And now we can do our little trick. We set what equal to what? 3y equals 2. Solve it. Y is going to be, yep, 2/3, 0.67. If you want to put a decimal, it doesn't matter. I'll take either. What questions do we have there? Nothing? We good? Okay, number 13. I want you to try this one. Okay, we look at our two bases. 4 is obviously the smaller one. Can I rewrite 8 to be a base of 4? No. Gotta think smaller. What'd you pick? 2? Good. 2 will work. So when we rewrite 4, we write that as 2 squared times 3x, yep, which gives me 6x. And then 8 is going to become 2 cubed and keep that old exponent. So my equation will now read 6x equals 3x minus 3. Solve it out. Subtract that 3x over. 3x equals negative 3. And x is going to be negative 1. Any questions there? Are we golden? Okay. Moving on to number 16. Okay. We look at our two bases here. Okay. Again, when we look at fractions, we are really only worried about the denominator when we're talking bases. Okay. So we got a 4 and we have a 32. Okay. Can I rewrite 32 to be a base of 4? No. We cannot. So think smaller. 2. Should we try 2? Okay. Let's do it. 2 to the first is 2. What's 2 squared? 4. 2 cubed. 8. 2 to the fourth. And 2 to the fifth. 32. Perfect. This is going to work out for me. Okay. My biggest question is, and a lot of us screwed this up on the quiz. Okay. So this is something we definitely want to think about, okay, and even test it in your calculator and see, how could I write 1/4 with a base of 2? Where do you see 4? Didn't I just find a 4 over here? So 2 squared is 4. So 2 to what power is going to be 1/4? Negative 2. So we can rewrite this as 2 to the negative 2. Okay, we really got to use our brain on that. We'll keep the old exponent. And then 32, that one's pretty easy. That's just 2 to the fifth, and then keep the old exponent. Left side of the equation is now going to be what? Negative 4x, and the right side? 20x minus 10. And then we solve it. Negative 24x equals negative 10. Divide by negative 24. And tell me what is negative 10 divided by negative 24. Five over 12. If you put a decimal, that's fine. What is the decimal? 0.4. Okay, that works. What questions do we got here? All right, do number 17. After that, we'll go to the next page. Ready, set, go. Okay, looking at my two bases. The smaller of the two numbers is the 27, but can we rewrite 81 to be a base of 27? Probably not. What'd you pick instead? 3. Okay. So 1 over 27. How would you rewrite that with a base of 3? I didn't hear that. Negative third power, because 3 to the third is 27. So 3 to the negative third would be 1 over 27. Good. Good, good, good. Keep our 3x. What about 81? 3 to the fourth. And keep the old one. What questions do we have there? Is this starting to click? Yeah. Okay, the fraction ones just kind of give us a headache, but they're not too difficult. If we practice them, we should be fine. Left side of my equation then is going to be negative 9x, and the right side 8x plus 4. Then we subtract the 8x. Negative 17x equals 4. Divide it. Yeah, we can't simplify that. It's just negative 4 over 17. Okay. You could put a decimal too if you want. It doesn't matter. Any questions on that? No? Okay, here we go, here we go. Next up, Okay, what happens if a common base is just not gonna happen? It's just not in the cards for us, okay? When this happens, what we wanna do, we wanna get the exponent, the base that has the exponent, on a side by itself, okay? And then we are turning this baby into a log, okay? Expanding and solving. So, for instance, this first example here, we look at our two bases, 2 and 61. Obviously, 2 is smaller, okay? Can I rewrite 61 to be a base of 2? No, I cannot, okay? And if I think of smaller numbers than 2, really the only one we have is 1, right? And taking 1 to an exponent is not going to do me any good. It's just going to be 1, okay? So, therefore, this is not a compatible base one, okay? This is one that we have to turn it into a log. But the good news is we already know how to do this. We did this on day 1. Okay, if this is isolated, is it? The base with the exponent's isolated? Yes. Okay, so we can go ahead, write log. The base is, nope, that's the exponent. Yep, the base is 2 of 61 equals the exponent, which in this case is x. And then we learn that there is a formula, there's a way to type that into my calculator, even though my calculator only does base 10. How would I do that? Log of opposite. Yep, log of the a value divided by log of the base. So log of 61 divided by log of 2. 5.9, we'll round it. Did we all get 5.9? Okay, any questions there? Go ahead and try number 4. Work with your group. Okay, is the base that has the exponent on it, is it isolated? Yep, so what can I do? How'd you solve it? Log base 8 of 92 equals, not x, m minus 7. Good. Good, good, good. Okay, we can type that left side into our calculator by just doing log of 92 divided by log of 8. What's that going to be? 2.17. Can we just call it 2.2? Sure. Okay, equals m minus 7. And then we need to add 7. And the answer is 9.2. Questions there? We okay with that? Okay, number 5 and number 6 are going to work very, very similar, except for, okay, the first thing we do is we isolate the base that has the exponent. So in this case on number 5, is that base that has the exponent, in this case 7, is that isolated? How would I get it isolated? Not minus 6, it's being multiplied. Divide it. Yep, what is 148 divided by 4? 37. And then we'd set up our log. Our base is 7 of 37 equals n. Log 37 divided by log 7 would be 1.9. And that's it. So really no different, just gotta have that extra step of isolating. So number 6, we won't do it. Let's just talk through it. How would you isolate number 6? Yep, add the 5 over. Add the 5 over. Okay, moving right along, okay? We're gonna go ahead and jump down to number 9. There is one like this on the test. Okay, tell me here, what is the base that has the exponent? E. It's just e, right? The e is the only thing being taken to that exponent, okay? Nothing else. So we need to move everything else over. What should I move first?
Minus 2.
Good, minus 2. Okay, just like if that was 2x plus 2 equals 90. We're following the same steps here. So we minus 2 first, which gives me 2e to the x equals 88. And then we need to divide by 2. Good. We've got to divide that 2 over before we can do anything. So 88 divided by 2 is 44. Okay. Now, what we would typically do is we would take the log. Can I do that here? ln. Good, good, good. Thank you, Jackson. Okay. Anytime that we have a base of e, we have to remember that that's a natural log 1. Okay. So it's not log, it's ln. So we're going to take ln of 44, set it equal to the exponent, which is x. What is ln of 44? 3.8. We all agree with that? Did you guys all find the button? Okay. So that is it. I want you to go ahead and try number 10, please. Number 10 and number 11, and we'll be done for the day. Okay, 10 and 11, and then we'll be done for the day. So go ahead and try those. Okay, number 10, number 10, number 10 is our base that has the exponent on it. Is it isolated? Yeah, so what did you do?
ln 87 equals 3x.
ln of 87 equals 3x minus 5. What is ln of 87? 4.5? Is that what you said? Yeah. Add 5 over. 9.5 equals 3x.
3.2.
Okay, x equals 3.2. Do we all agree with him? 3.2. How many of us got that? Proud of you, proud of you. Any questions here? That just has to do with the base of the exponent. So if it's e, it's always going to be ln, but if it's a number, then it's going to be log. Okay, good question. Guys, James had a really good question. He said, how do I know if it's going to be a log or an ln? Okay, if it has an e in it, it's always going to be ln. Okay, if it doesn't have an e, if it's just a number, that's when it's log. Okay, any other questions? All right, let's do 11. Does 11 have an e in it? No. So we already know from the beginning we're going to be using log, right? Okay. But we don't have our base that has the exponent on it. We don't have that isolated, do we? No. What do we got to do on 11? Subtract the 1. Okay, so that gives me 5 times 9 to the v minus 1 equals 180. And then you said divide by the 5 in the front because it's being multiplied, and that's the inverse operation of multiplication. Is division. Good. That gives me 36. And now we set up a log. So we're doing log base 9 of 36. Perfect. How would you type log base 9 of 36 in your calculator? Yep, log 36 divided by log of 9, which is 1.6. Is that what you said? And is that my answer? Not quite. Plus 1. V equals 2.6. What questions do you got? Nothing? Nothing, nothing? Are we good? Are we ready for this 4-day weekend? We're not going to forget all this over the weekend? You promise?
Oh, I probably will, but I'll do my homework like after school.
Okay. Let's try not to. Let's try to remember it. All right. Thank you, guys.